Here we'll be covering the topic linear equations, right? A linear equation is an equation that where its variable has no power higher than 1. So we see stuff like x plus y plus c. These is equal to 9. This is a linear equation because the power of all these variables is 1. If I start to say x squared plus y, this is no longer an or a linear equation because of this power 2 here. So when we solve linear equations, we are basically solving for the unknown, right? We have some examples we're going to go through. X plus 2 is equal to 7. So therefore, we need to subtract 2 on both sides to get x is equal to, and this will be 5 actually, right? Then we have x minus 3 is equal to 8. We add 3 on both sides, so x will be equal to 11. We have x divided by 6. So we need to multiply 6 on both sides, so x will be equal to 13. We have 5x is equal to 35. 5 is multiplying by x, so we divide 5 on both sides, so x will be equal to 35 divided by 5, which is 7. Now for this one, it's a little different because we have 2 x terms and 2 constant terms. So what we can say is we have to put, we always know that we have to put all like variables on one side. Or this is the variable that we are solving for, right? On one side. So therefore, we could put 5x across here, or we could put 2x across here. Any one is fine. So I'm going to bring 2x across. I'm going to say 5x, and that's going to be minus 2x equals, and I have a 9. I already had a positive 9. And of course, I'll send across the constant on the other side. So this is going to be add 3. So remember, if it's subtracting, it's going to add across here. If it's adding, it's going to minus across here. That's why we ended up with 5x minus 2x, right? And then 9 plus 3. So that's just the shortcut. You know it's one way on one side, you do the inverse of the operation on the other side. So we end up with, we know 5 minus 2 is 3, so 3x is equal to 12, and therefore 3 is multiplying by x. So to make x a subject of the formula, we divide by 3 on both sides, or we just say multiplication, we send it across to divide. So x is equal to 12 divided by 3, which is 4. Now for this example at the bottom here, we have 2 brackets equal to something. We know that we have to distribute or expand these brackets before we can do anything. So we can say 6x, 2 by 3x minus 10 is equal to 8. And of course, we are solving for x, so we're moving away all the other constants from around x. So the first thing we have to do is add 10 on both sides. So 6x is equal to 18, and divide by 6, x is equal to 3. Now we have a fraction here, or fractions. Of course, we find the LCM of this. When you see things like this, pause and ask yourself, what would I usually do in a situation like this if it was fractions? You know, find the LCM, so that's what you do. The LCM here is 9, so we put back 4x. And of course, 3 goes into 9 3 times, so we multiply the entire numerator by 3. And we put back 4 over 9. So now we are going to distribute and simplify, right? So that's going to give us 4x minus 9x minus 6 over 9 is equal to 4 over 9. So if you look at this, right, if I have x is equal to 2, it's equal to 1 over 2. The fact that they have the same denominators and they are equal to each other means to tell me that these two things are equal to each other as well. Because x over 2 is equal to 1 over 2. if I put 2 over 2 is equal to 1 over 2, I know that this is incorrect because they are not equal to each other. So if I have x over 2 is equal to 1 over 2, the fact that the denominators are the same makes our numerators the same. So we can simply put, or we can simplify 4x minus 9x, which will give us negative 5x minus 6 is equal to 4. So they had the same denominators, so we just put the numerators equal to each other and we solve accordingly. So minus 5x is equal to 4 plus 6, which is 10. And then x is equal to, so I know you're seeing a negative, so you might want to say 10 plus 5. But remember, this is not subtraction, this is multiplication. It's negative 5 multiplying by x. So if we're moving negative 5, we need to send it across the divide. So it's going to be 10 divided by negative 5, which is negative 2. So x is equal to negative 2 in this example. All right, so let's attempt this or these questions here. So the first thing we have is x plus 8 is equal to 1. We know that we need to move the 8, so it's going to be x is equal to 1 minus 8, which is negative 7.
So if it was reversed and I put the 8 minus 1.
It's okay. No, it wouldn't be correct.
So the number that you're carrying across must
X
always go
plus 8 is equal to 1.
in the back of the number.
It doesn't matter. It doesn't matter if it's at the back or if it's at the front. It's more the signs that we want to worry about. So x is equal to 1 minus 8. All right? It doesn't matter. It could be minus 8 plus 1 as well. But it can't be 1. It can be minus 1 at 8 or 8 minus 1. So this will give us negative 7. Okay, so for number 2, again, we are moving the 7. So it's positive 7, so we have to subtract on both sides. So x is going to be equal to 16 minus 7, which is now 9. Then we say it's subtracting 2, so we have to add 2 on both sides. So x is equal to 5 add 2, which is 7. All right, so 7a is equal to 42. We have to divide by 7 on both sides. So a will now be equal to 42 divided by 7, which is 6. Same thing, x would be equal to 20 divided by 5, which is 4, because the inverse of multiplication is division. Now for this one, when we have two fractions equal to each other, we can cross multiply. Right, so what we can do is, you know, the base multiplies by the top and the base multiplies by the top. So that's going to give me 45x is equal to 14. X is equal to 14 over 45. Do not be afraid if you see something looking a little weird like this. We are doing mathematics. So the first thing we need to do is add 7 on both sides. So 5x. We'll end up with 5x is equal to 11. And then of course we divide by x on both sides. So x is equal to 11 over 5, which can be written as 2 and a fifth, or 2.2. 5 is equal to 3y plus 2. Of course, remember our goal is to solve for y, no matter if it's on the left or it's on the right. So we remove the 2 first. So that's going to be 5 minus 2, we subtract 2 on both sides, so 3 is equal to 3y. We divide by 3 on both sides, so 1 is equal to y. Y is equal to 1, same thing. And for number 9, we add 3 on both sides, so we end up with 6x is equal to 18. And of course, we divide by 6 on both sides, so x will be equal to 3. I hope that this is becoming much easier for you all. When we meet an equation like this, we have to remember to put all our unknown, right? Our unknown terms, or the terms that we're solving for, on one side and everything else on the other side, equals to everything else, right? So what we're going to do is we're going to bring across the 3x to the 6x, right? We could do that, or we could carry the 6x by the 3x, anyone is fine. So we're minusing. Always remember what your signs. 3x is positive, so we're moving the entire thing across, so it's going to come across as negative 3x. 11 stays positive, and we bring across the 5 as negative, or subtract negative 3x on both sides, subtract negative 5 on both sides. So we end up with 3x is equal to 6, and we end up with x is equal to 6 over 3, which is 2. So we do the same thing for number 11. We could bring across negative x or add an x on both sides. So we end up with 3x, add x, and then we end up with 3, add 4, which will give us 4x is equal to 7, which will give us x is equal to 7 over 4. And of course, we know that's 1 and 3 over 4, or 1.75. For number 12, same thing again. 3y add 2y is equal to 7 minus 2. 5y is equal to 5. Y is equal to 5 over 5, which is equal to 1. So you have to keep repeating these rules in your head, repeating, what is the opposite operation of addition, subtraction, multiplication, division, should I add, should I divide, etc. all the time as you go through the question. All right, so what do we do for number 13? Of course, we see some distribution there, so we get right into it. 4 by 2. X is 8x, 4 by 3 is 12, is equal to 9 by 3, which is 27x, 9 by negative 5, which is negative 45. And we are right back to where we were in the previous question. So we put all the x's on one side. So I can say 8x minus 27x is equal to negative 45 minus 12. Of course, they can be on different sides, and the signs may look a little different according to which one you move. Just take your time. So this will then give us negative 19x is equal to negative 57. And of course, we send across that negative 19 to divide, or we divide negative 19 on both sides. And x will be negative 57 over negative 19, which will give us positive 3. We go again, 3x plus 12 is equal to 5x minus 30. So the distribution stops there, and we just put plus 32. We can say 3x minus 5x, which will be equal to negative 30 stays, plus 32 stays, and we bring across negative 12, which will give us negative 2x, which will be equal to negative 30 plus 32 is 2, and 2 minus 12 is negative 10. And of course, we divide by negative 2 on both sides, so x will be negative 10 over negative 2, which is 5. Yes. Okay, number 15, 2x. Remember, if you see 2x minus something in brackets, that means this entire thing, this has to minus this entire thing. So x and 4 are both subjected to the negative sign. So it comes like we have a negative 1 there, which we have to distribute now. So that will be 2x minus x, because we're multiplying negative 1 by x, and then negative 1 by 4, which is 0. Of course, 2x minus x will just give me 1x, minus 4 is equal to 0. And of course, I'm solving for x, so I add 4 on both sides, so x is equal to positive 4. Okay, number 16, we are seeing fractions, and I don't want you all to be afraid. Actually, we should be very happy because we're seeing that they have the same denominator. So we know that this is just going to be x at 3 over 4, because remember, when they have the same denominator, we can add the numerators. So all of this is equal to 1. What do we know about fractions equal to other fractions? We can put this as 1 over 1. We know that we can cross multiply. So this would be x plus 3, which will be equal to, so we multiply here by here and here by here, which will be equal to 4. So x will now be equal to 4 minus 3. X would be equal to 1. You know, something that looked, so quote unquote difficult was very easy, right? So let's move on to number 17. Again, we have fractions, but now we don't have the same denominator. So we know, according to the rules of fractions, we find the same denominator, which is the lowest common multiple, the LCM. So 14, 7 into 14 is 2. 2 by 5x is 10x. And then we just put back minus x because it was already over 14. This is all over 9 over 7. So we can simplify this. 10x minus x, which is like 1x, will be 9x over 14, which is equal to 9 over 7. We are back to the place where we have a fraction equal to another fraction and we cross multiply. So that's going to give me 63x is equal to 120. 126. Yeah, 63. And x will now be equal to 126 over 63, which is 2. All right, so number 18 now, it looks like what? Fractions, letters, regular fractions, what's happening? Same thing we would have done if these were regular numbers. We put all the x's on one side, so 2 third x, I can say minus 5 over 6x is equal to, I put back my negative 2 third and I add my 1 over 6 because of course I'm bringing it on the other side. So I can work that out. 2 third, I could go to my calculator, open brackets, 2 fractions sine 3 minus open brackets 5 fractions sine 6, and I'll get negative 1/6 in my calculator. Don't forget to put back your x. Go back to my calculator, open brackets, negative 2 fractions sine 3, add open brackets 1 fraction sine 6. Please use your calculators, it will save you a lot of time, right? And we have that. Now we know x is equal to, we have to send negative 1/6 to divide, even though it looks like, also complicated, it is not. So negative 1 over 2 divided by open brackets, fraction sign negative 1 over 6, close brackets, our answer is 3. So all of that to get a nice, cute, simple answer, x is equal to 3. So I hope that you all, will continue to practice this and memorize your rules and all these different things for solving linear equations.